Hey guys, just want to give you some pointers on this without giving you the answers. So hopefully you know that we've been dealing with linear relationships, some linear models, linear functions, and exponential functions, exponential relationships. So two different types of mathematical, sets of like concepts and skills. Either way. With the linear models, we have y equals mx plus b as our form, our general form of the equation. For exponentials, we have y equals a times b to the x power, possibly plus k or minus k, as you can see here. So certain things I already know are like this is linear, y equals mx plus b is the format. Same here, it's y equals mx plus b. This one here is exponential. Again, it's because I can tell by the exponent being a variable, and it's also the y equals a times b to the x minus k format, or this one, y equals a times b to the x power. Again, it's exponential, so so sorry about that, but we know what an exponential equation looks like. Or sorry, a linear equation here, and we know what an exponential equation looks like, and we know what linear graphs look like, and what exponential graphs look like, so I can kind of narrow down my choices right away, and then eventually I can use the slope and the y-intercept to decide which is which. Again, the slope and the y-intercept for the, and that's aka the rate of change and the initial value. Again, rate of change, initial value. For the exponentials, you also have your initial value is the a, right? Remember, it's a times b to the x power. Your initial value is this number. Your rate of change is this number. And then you have a y-intercept. Also, your y-intercept is is different sometimes when because normally your initial value is here. But if you have a minus 4, that's going to move your y-intercept down 4 spaces. So either way, you can definitely take a lot of information away from these equations to try to match them with these graphs. And so hopefully that is enough info to match those up. Here, determine if the following exponential functions are growth or decay. So all I have to do to look at these equations and decide if it's growth or decay is I actually have to look at the base number with the exponent, not this number out here, right? Not the a value. I need the b value, the base of the exponent. So anyhow, depending on what the base is, right? Like this base is 3, over here the base is 0.5, down here the base is 0.74. And here it's 98, so, and then I'll decide if it's growth or decay and give an explanation. So bottom line with these exponentials is if the base is greater than 1, it's growth. If the base is less than 1, it's decay. So again, that's if the base is greater than 1, you're talking about growth. If the base is less than 1, it's decay, and that's all I'm going to say about that. And then here, these can be a little tricky. You've seen this before, but certain things you haven't seen much of, especially like number 9. A town has a population of 7,893. The population of this town increases 12% each year. What you may not know is a percent increase is a multiplier. It's a constant multiplier. So that means it's exponential. If you're multiplying by the same thing every year or every time you get a next output, it's exponential. So again, if something is increasing by a percent or decreasing by a percent, that's an exponential type of growth or decay. And then another thing you're going to have to know is if something is increasing by 12% every year, your multiplier is 1.12, so I'm giving you part of the equation here. Again, it's exponential. I'm telling you that a percent increase is always a multiplying effect, which makes it exponential. And I'm also telling you that if If a population is increasing by 12%, that means that the entire population is still there plus 12 more percent, aka 100% of the population plus 12 more percent every year. So aka I'm multiplying by 112%, which is why my multiplier is 1.12 on this one. Again, my rate of change, my constant multiplier is 1.12, and you should know what the initial value is. This one, I don't think I need to chime in on this one. I'll leave that one be. This one, I'm also going to let it be, and this one. So I'll just leave you with, if you find that it is multiplying by the same amount every time or dividing, it's exponential. If you find that it is adding or subtracting the same amount, it's linear. And then be careful here, because these are only consecutive from -1 to 2. Once you get past 2, it skips to 12, 20, and 35. So you have to make your analysis with these first 4 ordered pairs. And don't forget, you can do things like figure out what they're adding or subtracting in this order, or you can go in backwards order to also figure it out. So even down here, you can use a calculator to divide these to see what they're multiplying by. So use a calculator, and if you find that something is linear, you're going to use the y equals mx plus b form, and if you find something is exponential, you're going to use the y equals a times b to the x power form. So that's all for this one.